Hello everyone, today I am here to present my model of solar oven which I have created for Bridge Interior Virtual Science Fair. A solar oven is a device which uses the energy of direct sunlight to heat, cook or pasteurize, drink and any other food materials. Many solar cookers that are currently in use are relatively inexpensive and are low technological devices. Since solar cookers use no fuel and cost nothing to operate, many non-profit organizations are promoting their use worldwide in order to help reduce fuel cost and air pollution, as well as to help slow down deforestation and desertification. The first academic description of the principles of a solar cooker is by a Swiss geologist and a mountaineer named Henri Benedict de Saussure in 1767. The principle of cooking meals from the sun was largely developed in the French Foreign Legion in the 1870s. Materials that are required to build a solar oven are a cardboard box, a knife or a scissor, aluminium foil, clear tape, plastic wrap, black construction paper, newspaper, a ruler and a thermometer. The basic principles on which a solar oven works is: first, concentrating sunlight. A mirror surfaced with high specular reflection is used to concentrate light from the sun into a small cooking area. Depending on the geometry of the surface, sunlight could be concentrated by several orders of magnitude, producing temperature high enough to melt salt or a metal. For most household solar cooking applications, such high temperatures are not really required. Solar cooking products are typically designed to achieve temperature of 65 degrees Celsius, that are a baking temperature, to 400 degrees Celsius, a grilling temperature on a sunny day. Its other principle is to convert light energy to heat energy. Solar cookers concentrate sunlight onto a receiver such as a cooking pan. The interaction between the light energy and the receiver material converts light to heat, and this is called as conduction. Pots and pans used on solar cookers should be matte black in color to maximize the absorption. The third principle is trapping heat energy. It is important to reduce convection by isolating the air inside the cooker from the air outside the cooker. Simply using a glass lid on your pot enhances light absorption from the top of the pan and provides a greenhouse effect that improves heat retention and minimizes convection loss. In resource-constrained settings, a high-temperature plastic bag can serve a similar function, trapping air inside and making it possible to reach temperature on cold and windy days similar to those possible on hot days. A food that is being prepared in a solar cooker is usually same as in an oven or a stovetop. However, because food cooks faster when it is in smaller pieces, food placed inside a solar oven is usually cut into smaller pieces that it might otherwise be. For very simple cooking, such as melting butter or cheese, a lid may not be needed and the food may be placed on an uncovered tray or in a bowl. If several foods are to be cooked separately, then they are placed in different containers. The cooking time in a solar oven depends primarily on the equipment being used, the amount of sunlight at the time, and the quantity of food that needs to be cooked. Air temperature, wind, and latitude also affect performance. Food cooks faster in the 2 hours before and after the local solar noon than it does in either the early morning or the late afternoon. Large quantities of food and food in large pieces take longer to cook. As a result, only general figures can be given for cooking time. It is difficult to burn a food in a solar cooker. Food that has been cooked even an hour longer than necessary is usually indistinguishable from minimally cooked food. The exception to this rule is some green vegetables, which quickly change from a perfectly cooked bright green to olive drab, which still retain the desirable texture. High-performance parabolic solar cookers and vacuum tube cookers can attain temperatures about 290 degrees Celsius, which is equal to 550 degrees Fahrenheit. And a conventional solar box cooker contain temperature up to 165 degrees Celsius, which is equal to 325 degrees Fahrenheit. Following are the advantages of a solar cooker. Solar cooker use no fuel, which saves cost as well as reduce environmental damage caused by fuel use. Since 2.5 billion people cook on open fire using biomass fuel, solar cookers could have large economic and environmental benefits by reducing deforestation. When solar cookers are used outside, they do not contribute inside heat potential, saving fuel cost for cooling. It also reduces carbon footprint by cooking without the use of carbon-based fuels or grid electricity from traditional resources. Thank you everyone.